Welcome to a lesson with Dr. Powell. Let's take a look at what a function is. A function is a mapping of routes between elements in a domain set to destination points in a codomain set. So 1, for instance, maps to 6, 2 maps to 7, 3 maps to 7. We could write f of 1 is equal to 6, f of 2 is equal to 7, and f of 3 is equal to 7. We could also write via the function f, we could, in the context, say that x maps to f of x. And so with this notation, we could say 1 maps to 6, 2 maps to 7, and 3 maps to 7. Notice that the codomain set may have some elements that are not hit by the function. The codomain is kind of like the data type of the output of the function, like what values are we looking for more generally for the output to be. But the specific output might not actually cover everything in that particular set. So the codomain could be actually larger. But when we define a function, we define the data type or the set of the domain and the set of the codomain. That's essential. And when we define a function, the range could be different than the codomain. What is the range? The range is the actual collection of points in the codomain that are hit via these assignments. We write, in function notation, we write f, a function from a domain set, let's call this domain set D, to a codomain set C. So this is the notation that we use for a function definition. We need two things. We need a function, we need something like this. So this is actually two things, a domain and a codomain, right? This notation tells us what the domain is and what the codomain is in sets, if we define what they are. And we also need some rule. And in our case, this amounts to being our rule, or maybe this information right here. Sometimes the rule is a formula or some algorithm or something like that, but for us, this is the rule. So there's a specific rule, and there's the declaration of what the domain set is and what the codomain set is. And a function is well defined if it follows all of these basic, if going through the rule actually takes something from the domain to the codomain. For instance, if we tried to define a function like this, f goes from the real numbers to the real numbers, and we said that the function definition was f of x is equal to the square root of x, we'd be in trouble. Since, for instance, if we plug in any negative number, we're not going to get a real number out, so this function would not be well defined. However, it could be well defined if we just simply change the codomain set or the output type. If we changed it to C for complex numbers, then all of a sudden f of x equaling square root of x is would represent a well-defined function. Thanks for watching.